Hi everybody. In this lesson we want to look at a few more examples about solving some rational equations. Okay, so let's get started. Now here's an example of a rational equation. It's an algebraic fractions involved in this equation, and so the general technique is to go ahead and multiply both sides by the common denominator. So the common denominator is going to have an x minus 2 and an x plus 4 in it. So let's multiply both sides by x plus 4 times x minus 2. And remember that that's really to be understood as a fraction over 1 because I'm going to multiply and that's going to be in the numerator. Now when I do that, you'll notice that the x minus 2's on this side are going to cancel and the x plus 4's on this side are going to cancel. So I just end up with 3 times x plus 4 on the left is equaling 5 times x minus 2 on the right. Now the purpose of this example is to illustrate that this particular rational equation was in the form of a proportion, right? The 3 is to the x minus 2 as the 5 is to x plus 4. So if you ever have a rational equation that is in the form of a proportion, then you can just cross multiply and notice that 3 times x plus 4 is exactly what I ended up with here, and 5 times x minus 2 here. So when you multiply both sides by the common denominator, if you have an equation that's like a proportion, that's the same thing as just cross multiplying. Alright, so let's finish it out. I get 3x plus 12 equaling 5x minus 10. Let's bring my 3x on this side. I'm going to subtract 3x from both sides. That'll give me 2x on this side. And I'm going to add 10 to both sides, or just think of bringing that minus 10 over here and adding it. That'd give me 22. Divide both sides by 2, and I get x equals 11. Alright, remember we always want to check our answer if we multiply both sides of an equation by a variable expression. In particular, I want to make sure that x doesn't equal 2 or negative 4, because then it would make division by 0 my original equation, and I would not have been able to multiply both sides by those values because you're only allowed to multiply by non-zero values. Okay, let's go on to the next problem here. So I have an equation. Again, it's a rational expression. Notice this is not in the form of a proportion. I can't just cross multiply here, so I'm going to have to multiply both sides by my least common denominator, which is going to have both an x and a 3x plus 1 in it. So let's multiply this side by x times 3x plus 1, and then this side also by x times 3x plus 1. Again, think of those as being over 1, because those are going to multiply the numerators. So here on this side you can see that 3x plus 1 is going to cancel, and I'll be left just with 2x. Alright, over on the right hand side I have to be careful to distribute that to each of the terms. And when I distribute it to the first term, I hope you can see that the x's are going to cancel, and I'll be left just with the 1 times the 3x plus 1. And then I'm going to go over the minus sign, so I need to carry the minus sign down here. When I distribute to the second term, the 3x plus 1's are going to cancel, and I'm left with this minus and the 6x and then the x right here. So that's going to be minus 6x squared. So when you get good at doing this, you can see that in just one very simple step, multiplying by the common denominator, this nasty looking algebraic fraction becomes much simpler. All the fractions go away. Alright, so at this stage I recognize that this is actually a quadratic equation because I got a square in it. So I'm going to bring all my terms on the left hand side in order to get a positive square term. And then I'm going to get 3x. If I bring that over, I'll get minus x, and bring the 1 over, that'll make minus 1. And I want 0 on one side so that then I can factor this and use the principle of zero product. So this will factor as 3x and 2x and 1 and 1, and if I put a minus with the 3 and a plus with the 1, here I'll get 6x squared, and then the outers are negative 3x, the inners are 2x, that makes a negative x, and the 1 times negative 1 makes negative 1. Alright, so now I can set each of these factors equal to 0. 3x plus 1 is 0, or 2x minus 1 is 0. So 3x is negative 1 and x is negative 1/3. Or 2x is 1 and x would be a half. All right? So there's my answers, except I also need to remember to check, right? When I come back to my original problem, you might notice that x equals negative 1/3. If I were to plug that in, that would make division by 0 right here. 3 times negative 1/3 is negative 1, plus 1 is 0. All right, so actually when I multiplied both sides by x times 3x plus 1, I should have said to myself, boy, I sure hope x doesn't equal 0, and I sure hope 3x plus 1 doesn't equal 0. But of course down here, 3x plus 1 did end up being 0. Okay, so I actually have to exclude this one. That one doesn't check. Does not check. Okay, so my only answer there is going to be x equals 1/2, and I could verify that on my calculator. Sometimes on a problem like this you get fractions, you wonder if it really is going to work. So one way to very quickly check that would be to just take 1/2 and store that as x on your handy dandy pocket calculator, and then just do both sides of the equation. 2 divided by 3x plus 1 gives me 0.8, and hopefully I'll get the same thing on the right hand side. So if I take 1 over my x value, that remember I stored x as a half up here, minus the 6x divided by that whole quantity, 3x plus 1, and I hit enter, and sure enough it's the same thing. And so that gives me great confidence that this is in fact the correct answer. Okay, let's do one last problem here. It says I have a function, and I like to find all values of a for which f of a is 1. Now we have to read very carefully here, because this problem does not say find f of 1. F of 1 would be plug 1 in here, and then it'd just give me 2 minus 6, which is negative 4. That would be very simple, but it doesn't say that. It says find all values of a for which f of a is 1. Well, now f of a means to plug a in here. So f of a is going to be 2a minus 6 over a, and the problem says find the value of a that makes that equal 1. So this gives me this equation right here to solve. So I need to solve this equation for a, and then that'll tell me the values of a that make that output of the function equal to 1. Alright, so let me come over here where I got just a little bit more room. 2a minus 6 over a equal 1. You see that this is a rational equation. I've got a fraction in it, so I'm going to multiply both sides by the common denominator. So if I multiply both sides by a, when I distribute the a here, I'll get 2a squared. When I distribute the a over here, you can see this a is going to cancel that a, and I'll just get the minus 6. So on this side I get 2a squared minus 6, and then over on this side I get a. I can bring the a over, and hopefully this will factor. So I need some factors of 6, probably 3 and 2. Let's put a 3 here and a 2 here. That would give me 4a and 3a. If I do that right, I can get negative 1 in the middle. Put the negative on the 2 and the plus on the 3. Negative 4a and 3a is negative a, and 3 times negative 2 is negative 6. Alright, so I've got either 2a plus 3 equals 0, or a minus 2 equals 0. So setting this equal to 0 and solving it gives me negative 3/2. Over here I get a equals 2. Alright, now notice the only potentially bad a would be a equals 0, and those neither one of those are 0. So I think these should be the answers. Let's just check. Let's check this one real quick. If I plug in 2, 2 times 2 is 4, and 6 over 2 is 3, and 4 minus 3, sure enough, that does give me 1. Okay? Now if I wanted to check this other one, I could again use my calculator. Let's turn it on here. And a is negative 3/2, so let's take negative 3 and divide it by 2. Let's just store that as x, because I got an x button that's a lot handier than hitting alpha a on my calculator. And then I'll do 2x minus 6 divided by x, and hopefully that'll equal 1, and sure enough it did. Okay?